Okay, so we are going to look at today what happens when you add a double bond to the carbon chain. But the rest of the principles or the fundamentals are going to be the same. Count the longest chain, and when you have to say where the double bond is, we are going to use the lowest number again. So we are going to do less, build up, and get right to the examples because we don't have to repeat the same things that we did before. You already know 1 carbon is meth, 2 carbons is eth, etc. Okay? So as soon as you have at least one double bond, then the ending is going to change to ene or ene. And in a very rare case, just like with, say you had 2 methyl groups or 2 ethyl groups, if you have 2 double bonds, you can put di. If you have 3 double bonds, then you would put tri. But that is very, 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 very rare. Okay? So when you have a double bond, because 2 carbons are involved, then that's an extra special case where we have to follow the lowest numbering. So you want to do the carbon that comes first. As soon as a carbon has a double bond attached to it, that is the number we're going to use. Because again, we want to follow the second rule of organic chemistry to use the lowest number. And once you have at least one double bond or triple bond, then the molecule is called unsaturated, which is part of the first lesson as well. This means that there is not the maximum number of atoms connected to the carbon chain. So when we do reactions after alcohols and ethers, then one of the things you can look for is where is there a double bond or where is there a triple bond, because that can be changed into single bonds. So when you use the model kits, the longer, skinnier, more flexible bonds were used to represent multiple bonds because those are more flexible, less strong, easier to break. Okay, so like I said, we can skip right or get right into the practice. Once you have a double bond or a triple bond, then we consider that to be the parent chain. So it actually kind of does make your life a little bit easier because then it's sort of, that can be, you can know that you're going to count that as part of the parent chain. We don't consider multiple bonds as in the branches. And so then more often than not, the questions are drawn sort of with the parent chain more obvious, which is helpful. So again, we want to try to use the lowest number. So if you start on the left-hand side, then carbon number 1, is there a double bond attached to carbon number 1? No. When we get to carbon 2, is there a double bond? Yes. And even though technically carbon 3 is involved as well, it's a higher number than 2. So we say that carbon number 2 has the double bond. So the longest chain is 1, 2, 3, 4, 5, or pent. As soon as you have a double bond, the ending will be different, E-N-E or ene. But again, if we wanted to draw pentene, then you would go do your skeleton and be like, okay, where do I put the double bond? Carbon number 2. Another convention to naming is because this 2 is out front, then it's not maybe as obvious what the 2 is referring to. So you'll see this written like this as well. And your textbook uses both ways. And one of the advantages of the second way is that it says pent 5, carbon 2 has the ene. Okay, but it doesn't really matter. Either way is fine. When you have a question like number 2, that's a ring. Okay, so regular rings, we would have said no beginning and no end. So every point could technically be carbon number 1. So the same is true here. Now, these 2 carbons have a double line, so there is an ene, but you could call this carbon 1, this one carbon 1, it doesn't matter, okay? So, just like the other regular cycloalkanes, you can write it like this. Oops, I got rid of the... But if you are stressed and you're like, Ms. Todd, if I start leaving out the numbers, then I'm going to do it every time, you could write this. Either of these would be acceptable. You could write cyclobute-1-ene. If you get into the second type of ending, all of those are the same. So for when you get to draw, then again, usually that is a more popular choice because you get to decide. I like to do the skeleton first and then fill it in. I like to count from left to right. No, I like to count from right to left, whatever. I like the stick formula. You can do that too. Whatever makes sense to you. So even if you do stick formula and even if you do the skeleton and you connect them only once, you can still go back and make another line for a double bond and it will work. Okay, so go to the end. What's the ending? Bute 4. Okay, if you find it helpful so you don't mess yourself up, whatever way you want to count, I'm going to start here. That's what I like. I like to do it left to right. If you like right to left, that's fine. And then carbon 3 has a methyl. Carbon 1 has the ene. And then when you go back in and do the ticks to represent the carbon, you just have to be careful because now that counts as 2. So carbon 1 has 1, 2, 3, 4. Carbon 2 has 1, 2, 3, 4. Carbon 3, 1, 2, 3, 4. But carbon 4 only has 1, needs 3. 1, 2, 3. If you're a stick person, okay, you can do that too, whatever way you like better. You can, if you're feeling fancy and you want to do condensed when you draw, you can do that too. Some people find it a little more frustrating because they're not necessarily sure how many hydrogens will go, but whatever. All versions are equal. Okay, so one of the things about organic chemistry is there are a lot of different what we call isomers. So when you have isomers or different arrangement of the atoms in space, then the chemical formula can actually be the same, which makes it not as useful. So as I said the other day, I'm not going to ask you to write C5H10 because it doesn't tell us anything about how the atoms are arranged. So this can matter for biology. So in biology, sometimes you call it L and D glucose, levorotary, dextrorotary, or alpha beta linkages, like the different arrangements of the atoms. If you looked up your molecule and you saw that it was drawn sort of in a kind of a weird shape, sometimes called chair and boat, then what they're showing is what we call stereoisomers. So if a molecule, so it's going to be an alkene or double bond, if a molecule is drawn to show the different spatial arrangements or the isomers, then you have to label it either cis or trans. And usually the textbook for the homework in this section, it's split it apart. Pay attention to cis and trans or don't. But another thing that you can do is take a look at how it's drawn. So if I just drew 2-butene and it didn't say anything about the kind of isomer we're talking about, then you would just draw this. Okay? But you can see that these two examples here, cis-2-butene and trans-2-butene, have been drawn in a very unique way. And sometimes it's called boat. Now this boat is sinking, but and chair. Okay, so when you have the cis isomer, what that means is around the double bond, whatever's left is on the same side. So in this case, it happens to be on the bottom. You could have drawn it on the top. And then in trans, whatever's left of the carbon chain around the double bond is on opposite sides. So in this case, they've done right and left. You could go the other way, like you could put the CH3 on this side and the other CH3 on that side. It just has to be on the opposite side, and we're always looking around the double bond. So when you get these kinds of questions, then it will be for an alkene only. And in grade 12, we don't usually mix them together. So we won't do like an alcohol and a sister trans isomer. But when you look at your huge molecule, you might find like you can draw sort of a boat conformation for glucose where it's like coming up, it looks like in the picture on the internet. So you might see that if you have a molecule that has rings in it, but we're gonna keep it to questions like this. Mm-hmm. Okay, so a question like this, draw the two stereoisomers of 2-pentene. You may find it helpful to draw 2-pentene first. Okay, so that's 5. So again, we are concerned about the cis part being for carbons around the double bond. The hydrogens are considered to be filler. So what I like to do is draw the double bond first. So I'll do cis first. Okay, so I'm going to draw the double bond first. And then I know I want the double bond to be on carbon number 2. So because this one is drawn sort of like an upside down boat, I'm going to draw it the other way, okay? So this is carbon 2. That means that carbon 1 would be there. So 1, 2, double bond, 3, 4, 5. Okay, so they're on the rest of the carbon chain is on the same side of the double bond. Okay, and then for trans, I'm going to do the same thing. Draw the double bond, say where it is. I'm going to call this carbon number 2, but then you have to be a little bit more careful. So if this is number 1, if I draw number 1 like carbon number 1 on the top left, that means on the number 3, I have to go down because I want them to be opposite. If you drew this, then your opposite would be this side. That doesn't matter, okay? 1, 2, 3, 4, 5. So just make sure you're deliberate in whether it's the same, whether it's top or bottom, or it's opposite, okay? I need to know that you know which is which. Okay? And then you can have a triple bond with the ending YNE or -ine. And again, alkenes and alkynes are more reactive because you can change the single and double bond, or sorry, the double and triple bond into single bonds. Okay, so we're going to do the same thing. This is 1, 2, 3, so prop. You want to use the lowest number. Ine for the triple bond. So carbon number 1 has a triple bond. So whether you like 1 propyne or prop 1-ine is okay. The second example, I'm going to show you when you have to use the dashed ending because you have more than one ending. Okay, so if you have an ine and an ene, then you have to be able to do the second dashed ending. But again, some people like it because then you can see the number goes right with the ending. So this carbon on the left would be number 1. Number 2, and then number 3 has the ENE. And try your best to do alphabetical order. So 1, 2, 3, 4, 5 is pent. So 3 ene, 1 ine. If you write the ine first because it has a number 1, I won't take marks off, but again, I can't guarantee your organic prof will not. Okay, and then the last kind of compound that has hydrogens and carbons only in their chains is aromatic hydrocarbons. And aromatic implies, oh, what a nice smell, right? Aromatherapy. So the chemistry, benzene is a very, very stable, which is unfortunate because it's a very, 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 very toxic molecule. So when it says very smelly, what that means is, like, if I opened it and spilled a little bit, all of you would be throwing up. The smell itself is so toxic. Your body's like, get this out of me. So it is so, so, so bad. So if you are a commercial watcher, sometimes there are commercials for cigarettes or other substances that are man-made, and they use benzene or benzene derivatives as a preservative, and it's carcinogenic, and they say in the ad that that's bad for you, which is true, okay? But they are very, very, very interesting, I guess, from a chemistry standpoint. So technically what happens is that there are alternating double bonds. So carbon, single bond, double bond, single bond, double bond, single bond. So what we do, because this is a lot of writing, we usually use the form in the middle with a circle inside, showing that as long as the double bonds are alternating, then it's benzene. And you always have 6 carbons. So it'll look like a hexagon, but the circle inside means it's benzene. Okay? But it is good because it does sort of follow the same convention as regular cyclostructures. So for example, this one has, I don't know why those are there, no beginning and no end. So what that means is you call the parent benzene, and then this is a methyl group because it's one carbon, and this is carbon 1. This could be carbon 1. Who cares? If you have 2 groups substituted, this bromine could be on number 1, the chlorine could be on number 1, doesn't matter. Which makes your life a little bit easier. Okay, and again, less common question. What happens when benzene is not the longest chain? Then we use the word phenyl, P-H-E-N-Y-L. Okay, so technically this is 7. 1, 2, 3, 4, 5, 6, 7. So then because 7 is longer than 6, we would call this 2-phenyl heptane. Your textbook is sneaky, and they put one like this one in the homework. So really, this is only 4, 1, 2, 3, 4, but because of the double bond, then it has to be the parent. So that is very, 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 very sneaky. I don't like that, but I just wanted to show you this one because it's definitely, they sneak one in.